So, good morning. My name is Michael. I'm a PhD student in the school and clinical child psychology program. I would like to thank the CSA for putting this conference together. It's my first time presenting here, and for giving me the opportunity to speak about something very different from all the other presenters. So, I will be discussing what type of inhibition underpins performance on Luria's fist edge palm task. So the fist edge palm task, or FEP task, is a bedside assessment commonly used to assess frontal lobe and psychomotor functioning and has been extensively utilized to detect voluntary movement disorders. During the FEP tasks, patients are required to reproduce a sequence of hand movements on a flat surface in the fist edge palm arrangement for a certain number of cycles. A central challenge inherent in correct performance of this task is the inhibition of the prepotent but incorrect hand movements associated with the task. For example, participants must not perform the flat hand movement following the fist hand movement, but instead must perform the edge hand movement. However, a surprising lack of knowledge of the cognitive mechanisms underpinning the FEP task exists. Are the inhibitory control mechanisms associated with successful performance of the FEP task located in the left or in the right prefrontal cortex? Well, some recent neuroimaging work does suggest that FEP performance might rely on similar inhibitory control mechanisms as those underpinning the Hailing test, which is a sentence completion test used in neuropsychology and relies on the integrity of the right prefrontal cortex. Thus, the aim of our study was to investigate the neural basis of the FEP task by examining whether performance on the Stroop test, which is left prefrontal cortex sensitive, or Hailing test, right prefrontal cortex sensitive, or fluid intelligence, global prefrontal cortex functioning, can predict FEP performance. Our hypothesis was that the Hailing test performance would be predictive of FEP performance, indicating that FEP performance relies on the integrity of the right prefrontal cortex. So what do we find out? Well, we discovered that participants' score on the Hailing sentence completion test was able to significantly predict FEP task performance. It was able to predict the overall FEP score, which is the chart on the left, and it was also able to predict the number of crude errors or incorrect hand positions participants made on the FEP test. Performance on the Stroop test was not a significant predictor, and this is likely because the Stroop test is associated with left prefrontal cortex functioning, while the FEP task is associated with right prefrontal cortex functioning. In the same way, fluid intelligence was not a significant predictor either, due to its sensitivity towards global prefrontal cortex functioning and not strictly the right prefrontal cortex. So what does this all mean? Well, our findings suggest that performance on the FEP test can be predicted by performance on the Hailing sentence completion test. And what this means is that we've provided evidence indicating that right, but not left, prefrontal cortex inhibition functions underpin successful performance on Luria's fist edge palm task. So these findings dramatically increase the clinical utility of this much used neuropsychological assessment. To continue to develop the diagnostic reliability of the FEP test, our research team in the United Kingdom is now collecting clinical data to assess whether patients with damage to the right side of the prefrontal cortex perform worse on the FEP test compared to those with damage to the left side of the prefrontal cortex. At this moment, I'd like to thank you for your attention. I'd like to thank my supervisors and collaborators, and of course, the ongoing support from the hospitals and brain injury wards in the United